In the heart of the Middle East, the military balance is always shifting. Iran's acquisition of China's HQ-9B long-range air defense system has raised one question. Could it really shoot down Israeli jets, especially the stealthy F-35 and powerful F-15? Today, we'll break down the HQ-9B's capabilities, Israeli Air Force technology, and run a simulated battle scenario to see if the HQ-9B could change the air war game. The HQ-9B is China's flagship long-range surface-to-air missile system, often compared to the Russian S-300 or even the S-400. Range: up to 250 to 300 kilometers against aircraft speed. Mach 4.2. Guidance netting active radar homing with anti-jamming capabilities. Altitude coverage: up to 27 kilometers for aircraft, lower for missiles. Target tracking can engage up to 6 targets simultaneously. In Iran's hands, the HQ-9B fills a critical gap in long-range interception, complementing older S-300 PMU-2 systems and the domestically built Bavar 373. Israel's air power is no joke. Its F-35I Adir stealth fighters are custom-built to evade radar detection and carry out deep strikes. Paired with the F-15I Ra'am, which carries heavy payloads for precision strikes, Israel has the most advanced air fleet in the region. Key Israeli air capabilities include stealth design and radar-absorbing coating, F-35I, advanced electronic warfare suites, long-range standoff missiles like the Delilah and Rampage high pilot training standards. For the HQ-9B to succeed, it must detect these jets early, resist jamming, and launch before Israeli missiles destroy it from a safe distance. The HQ-9B relies on a combination of Type 120 low-frequency radars and HT-233 fire control radars. While F-35 stealth is highly effective against high-frequency radars, lower-frequency radars can detect them, but usually with less precision. That means HQ-9B operators may detect something, but struggle to lock on until the jet is closer. Iran could improve detection by pairing HQ-9Bs with over-the-horizon radar systems, using passive detection systems to track emissions, integrating multiple radar types to close detection gaps. Let's run a simplified simulation based on open-source data. Scenario 1. F-35. I strike on Tehran. The F-35I approaches using terrain masking and electronic warfare. HQ-9B detects faint radar signature at 80 to 90 kilometers. Lock-on achieved only at approximately 55 kilometers. The F-35 launches standoff missiles at 100 kilometers. Result: HQ-9B site hit before it can fire. Stealth advantage wins. Scenario 2. F-15I. Air raid on coastal base. F-15I detected at 220 kilometers. HQ-9B launches 2 missiles per target at 180 kilometers. F-15I deploys chaff and jamming, but one is hit in simulation. Result: HQ-9B scores a kill but risks counterstrike from surviving aircraft. Scenario 3. Combined Israeli attack F-35s target HQ-9B radars while F-15 carry out bombing runs. Integrated Iranian defense responds with HQ-9B, S-300, and Bavar 373. Result: mixed. One Israeli jet damaged, but most survived to complete mission. Military analysts agree the HQ-9B is a formidable system, but it's not invincible. Against stealth aircraft like the F-35I, early detection is the biggest challenge. Against non-stealth jets like the F-15I, the HQ-9B stands a much better chance. However, no air defense system works in isolation. Its real strength is when it's part of a layered defense network, radars, short-range systems, and electronic warfare all working together. So, could Iran's HQ-9B shoot down Israeli jets? Yes, and especially older or non-stealth aircraft. But stealthy F-35s will be much harder to hit without a fully integrated detection network. In modern warfare, survival depends not on a single weapon, but on how all systems work together. The HQ-9B is a powerful piece of Iran's defensive puzzle, but the game in the skies remains wide open. If you enjoyed this analysis, hit like, subscribe, and tell us in the comments. What matchup should we simulate next?